In this video, we're going to talk about simulation techniques with random number generation. Now, as you work in data science and you start working in data in general, often one of the things that you want to do is simulate data, and random number generation can be really handy for that, and it can also be handy for game playing as well. So for demonstration purposes here, we're going to simulate rolling a six-sided die to get started. And part of what we're going to want to talk about is a concept called reproducibility, and basically how is it that we can ensure that somebody executing our code is going to be able to get the same results that we got. So let's go ahead and introduce random number generation. In order to do that, we're going to import a module called random. The random module, as you might guess, provides capabilities for random number generation. So in order to use it, we need to import it first. So this is similar to what we did earlier with the decimal module and the statistics module. In this case, rather than importing a specific function from the random module, we simply import the module itself, and the reason we chose that path is we're going to use a couple of different functions from that module. So let's go ahead now and try rolling a die a few times here. So we're going to use a for loop to do that, and we're going to say that we want to loop 10 times. So we've done a number of for loops like this earlier, and for each iteration of the loop we're going to print out a randomly generated integer. So we're going to use the random module's rand range function to do that. And you might be able to guess that rand range is kind of like range. It produces a range of values, but in the case of random number generations, it produces one value in that range. So if I say 1 and 7, what I'm going to get back every time I call rand range with these two arguments is a number in the range 1 through 6, that is starting from 1 up to but not including 7, and that's going to be an integer value that's returned. And let's go ahead and display these on one line like we've done a number of times. So you can see here that we get a certain set of values. Not all of the values in the range were produced. I got a couple of 6s, a few 5s, a few 1s, and a 3. It looks like I'm missing all the 2s and 4s at this point, but if I recall that snippet and execute it again, I'm going to get different results. So this time we have a 2 and a 4. Actually, we have several 2s, and we got a little bit better distribution of values the second time we executed that statement. Now, each time I execute that loop, it's going to give me a new set of values. However, there is a capability for forcing the random number generator to give me the same sequence of values every single time, which would be important for reproducibility. And again, that is a key concept as you start working with data and you're doing studies and you want other people to be able to reproduce your results. So there are a number of cases throughout later lessons where you're going to need to seed a random number generator to ensure that you get the same sequence of values each time, and we'll talk more about that momentarily. Now in this example, or in this video rather, one of the things I want to do is show you the script figure04_01.py, which is going to take what we did here with random number generation, and we're going to roll a die 6 million times. Now, if we roll a die 6 million times and it's a well-balanced die, we should get approximately 1 million of each face. Similarly, if it's a good random number generator, we should get approximately 1 million of each face as well. So previously, when we've executed scripts, we did that from the command line, not in IPython interactive mode, but it turns out you can run scripts from interactive mode as well by using the run command. So let's go ahead and take a look at that. And if I execute the first of these scripts here, which is the key one for this example, You can see that it's hanging a little bit. It's actually calculating 6 million rolls at the moment, and in a few moments, there we go, it'll display the results. So you see the 6 different faces, and you see that each one of those faces occurred approximately 1 million times. Let's run it again, and in a moment the results will be displayed. You may notice, if you're coming from another programming language, that because Python is interpreted, it may not execute certain things as quickly as compiled languages do. But it did still come back relatively quickly, and though we got different results this time, it is random, we got still approximately 1 million of each face. So that demonstrates how to run a script in the context of IPython. Now let's switch over to the script code for a moment here. And for this example, where since we haven't gone in depth into some things like lists yet, where we could potentially use a list to keep track of each die face, what we're going to do in this example is define 6 separate variables that represent the 6 different faces of the die, and we'll keep track of how many times we roll each face by using an if, elif, else statement nested in a for loop. So here we have a for loop that's going to iterate 6 million times. Notice the use of underscore in a numeric literal here. This can be used to improve the readability of your literal values. It appears that my editor is not understanding the fact that this is actually the number 6 million. So let me just show you that if I remove those for a moment, now it's colored all the digits correctly in that case. So that's a bug in this particular editor. But in any case, we're going to iterate 6 million times, and each time through we're going to use that rand range call we just demonstrated to get one face value. Then we're going to check if the face is a 1, 2, 3, 4, 5, or 6, and for whichever one of those cases is true, we will add 1 to the appropriate counter. Now, if you look down below, once we've iterated 6 million times, we then have some print statements that are going to produce the table that you saw. First, we're displaying a formatted string that has the literal characters for the word face, and then a placeholder in which we display the string frequency right aligned in a field of 13 characters. So right justified, right aligned in a field of 13 characters, which gives us the 2-column format. And for the subsequent lines, we display the value 1 right aligned in a field of 4, then the value 2 right aligned in a field of 4 for the numbers from 1 through 6, and for each of the frequencies we also display those such that they'll appear right aligned under frequency, so that each of these is also displayed in a right aligned field of 13 characters. So that's what produced the output that you saw in my interactive IPython session here. Now, I did promise you that we would talk a little bit more about this reproducibility issue. It turns out that the random module has built into it the capability of doing what we call seeding the random number generator. There is a seed function which, when you call it with the same value, is going to restart the random number generation from that particular seed value. And basically, it's not true random numbers that you're getting, but rather pseudo-random numbers that are produced by a complex calculation underneath the hood. That complex calculation by default starts with a seed based on the system clock in most implementations, but if you seed it with a fixed value, then you can get the same sequence of values each time. So let's demonstrate that capability. Let's call random.seed, and we'll give it the value 32. And let's recall the for loop that we did up above. Now, for anything that we do from this point forward is going to start with the sequence seeded at the number 32. So if I execute this, I'll get 10 values, and they'll be different from what we had up above because these started from a different seed point. If I execute the same loop again, I'm going to get different values because it's going to continue from wherever we left off in the preceding rand range call. So we do in fact get different values here down below. So you're not seeing the reproducibility yet. The way you see the reproducibility is by recalling that snippet that seeds the random number generator. So now we're starting over from the same point we started at back in snippet number 6. And now if I recall that for loop, you can see that the values produced here are identical to the values produced back in snippet number 7. So if you want to produce random data for simulation purposes, and you need the ability for somebody to get the same set of random values for testing purposes, you can seed the random number generator to a specific value, then produce all your random numbers. Then somebody else coming along and running your same code with the same seed should get the exact same results.